Well, hey, it's Dr. J, and as promised, I'm back with an application of the definite integral and the area between two curves that was discussed in the last video. This is a little bit of economic theory, sort of overlapping with calculus. So this is where I change hats, although I only have this one hat. So um, I'm now your economics and calculus professor for this lecture. Now, we've already done a little bit of economic theory. You might recall what's called the price demand function or equation. I've used both words. Price demand, this is where you say P of X. Let me just use one that I'm going to use in the problem today. So let's say it's negative 0.03 x plus 24. I'm not saying that you need to recall this exact equation, but this is, a type of price demand equation that we have discussed in the past. It can also be written like this, just simply as an equation. P equals negative 0.3 x plus 24. Yeah, so this is the function notation, and this is just the standard equation notation. Okay. Well, today we will use the notation P equals capital D of X. And we've kind of already been doing this. I'm just introducing a new letter, capital D. And that's because we're emphasizing today demand. So this equation tells you that price is a function of demand. So again, I'm not changing any of the mathematics that we've done in previous lessons. I'm just introducing a new letter, capital D, for demand. All right. And so we will call this function the demand function. Yeah. You can still call it the price demand function. That's what I called it in the past. But in today's lecture, the price will be the y value. I think that was already true. So the price is the y value. That's like your y-axis, or that is your y-axis. And then your demand is x. Yeah. And then the line, which we used to call P of X, we're just now calling D of X. And it means exactly the same thing. It basically is just saying that the y value is P. Yeah, so P is the y value. It's the output. Yeah, and then X is the input. And that's the equation, or that's the function that we're going to be using today in this lecture. And then there's something new. And this is actually new, called the supply function. Again, P is the y value, and S is the supply function. And it kind of goes like this. So the demand function starts at positive 24. That's the y-intercept. And then the slope is negative, and it goes down. I'm not using the grid to be very precise here. And then you have, let's say, if that's 24, that's 12. So we'll say this is 8. This is the supply function. And I want to make this very clear here. Supply curve, or the supply function. We sometimes call it a curve. I mentioned this in my last video. Even when a graph is a straight line, we call it a curve. It's just called a linear curve. So supply goes up. And the supply function I'm using is positive 0.1x, 0.01 x plus 8. So supply is increasing. And then demand is decreasing. There we go. And so this is classic economics 101. Intro to economics. Supply is increasing, demand is decreasing, and the point where they intersect is called the equilibrium point. The notation for equilibrium point is x sub 0, p sub 0. Remember, p is like y. The subscript 0 is just used to indicate that it's a specific point in which the two intersect. Now, in this example, I'm going to go ahead and give it to you. P sub 0 is 12. Did that pretty good. And x sub 0 comes out to be 400. Now, I'm trying to just introduce the concept, so I'm not going to show you how I got the 12 and the 400. I will show you that later in this lesson. So just for now, just trust me. These two lines intersect when x is equal to 400. That's the demand, right? That's the number of units or the number of items, right? Demanded. And then P is the price, which I think I already mentioned, usually in dollars. I'll just put a dollar sign here. So $12, 400 units will be demanded. Yeah. Okay. And this entire arena or world that we live in is called the market. Right? It's a concept. It's an abstract concept. Right? We think of there being this thing called the market, right? You can imagine, if you literally had a physical space in which you had X number of people, right? And you're out there hustling, 400 people would buy this product if it was priced at $12, whatever this product happens to be. Widgets, gadgets, gizmos, whatever. All right, so that is the market. This is what we're dealing with today. And so the title of the lecture is Consumer Surplus and Producer's Surplus. So how do we do that? We get into the calculus now. So this is, where does the economics and the calculus intersect, right? So we start by removing the supply curve. So this is called consumers surplus. So when you do consumer surplus, you remove the supply curve and you look only at the demand curve, right? And then you draw a horizontal line through the equilibrium point. This is the line P equals P0. Now remember, P is your Y. You could actually say Y equals P0. I mean, you could do that. I know I've done that in the past when we were graphing. I would say, well, this is X and this is Y. But I'm being very strict following the notation of the text. So I'm removing the supply curve altogether, and I'm looking only at the consumer. Okay. And so remember, this point here is 12, 400. So this line is P equals 12. Notice P0 is 12. This is one particular point. This is the horizontal line. All of the demand, all possible demands in which the price is $12. And it goes right through the equilibrium point. So, how does this work? Well, let's just think about it for a second. Suppose the price was $20. Right. And again, my graph doesn't have to be to scale. So suppose the price is $20, right? Which is above the equilibrium point. On the demand curve, and again, we call it a curve when it's really just a line, that is above the equilibrium point. Right? You can pick any price. I'm just randomly picking $20. It really doesn't matter. Right? Well, you're going to have a certain number of people that are willing to buy this. That's a terrible line. That's supposed to be a straight line. But this price would correspond to less than 400 people. Right? You can think about how many people would buy it. That's called the demand. What is the demand at $20? What is the demand at $20? Well, I don't know. I have a function right here that tells you if you set the price to $20, you would just set the output equal to 20 and solve for X. Right? This is just basic algebra. So move the 24 over. Divide by negative 0.3, 0.03. Make sure you have your calculator handy. So negative divided by negative is going to be a positive. So 4 divided by 0.03. Oh, God, I picked a terrible price. I wish I would have picked $21. Here, let's try that. $21. Sure, yeah. Can I change my mind just to make the numbers come out nicer? I said you could pick any price, so let's pick $21. Right now, I'm just sort of introducing the concept anyway, so I can fudge the numbers here. So 0.03x. I just don't want to have repeating decimals. This is going to be 100. I was trying to avoid repeating decimals. So negative 3 divided by 0.03. Much nicer, yeah? Okay, cool. So a $21 price point, right? The demand is 100 people. So 100 people or 100 units. They don't necessarily have to be 100 people. You could have 100 people that each buy one, right? I guess that would be more realistic. Or you could have one person that bought all 100. It would mean the same thing. It just means 100 units are demanded. I mean, you could also have 50 people that each buy 2, yeah? Or you could have all possibilities in between there, right? So consumer surplus is basically saying, if you sell, look at all these different possible price points, yeah? $21, 100 people will buy it. You could sell it for less if the item or the product, let me call it the item, or sometimes called a commodity, is sold for less than $21. But more than $12, the consumer has a perceived savings. Yeah. The consumer thinks that they're saving money. Yeah, and so when they think they're saving money, they think, this is what you'll see this, you'll see at a store, they'll say the item is on sale, yeah? Any price between 21 and 12, you can think of as saving money, right? Because $21 is the demand price here. $12 is the equilibrium price. And you have all possible prices in between. Yeah. All possible prices between. All right, now what does this have to do with calculus? Well, think about it. That was just for $21. What if I did $22? Or what if I did $23? Or what if I did $19? I skipped 20, but whatever. Or what if I did, make it a rainbow here. What if I did $18, right? Can you see the calculus coming into play here? All possible prices would be the area of this triangle. So, the consumer's surplus is equal to the area of this region. Yeah, this region right here. And so that is the end of the introduction. No more messing around. Let's take some calculus now. So that would be equal to the integral from 0 to x0 of d of x, the demand function, that's your d of x, minus p0. P0 is this horizontal line here with respect to x. So let's go ahead and do it. Example 1. D of x is negative 0.03x plus 24. Equilibrium point is 400, 12. Consumer surplus is the integral from 0 to 400 of negative 0.03x plus 24 minus 12 dx. And that will tell us the area of this triangle here. It's basically adding up an infinite number of strips, little very skinny rectangles, right? You just think of them as a bunch of lines like this. And that represents all possible demands and the associated prices for everything between the equilibrium and the demand function. So that's the integral from 0 to 400 of negative 0.03x plus 12. I like to simplify before I integrate. Now we take the antiderivative and we evaluate it between 0 and 400. We've done this before. When the lower limit of integration is 0, you can pretty much ignore it. You can't ignore it, and you just plug in the upper limit. And there you go. So you got 400 squared. That's 160,000 times 0.03, which is negative, and then divided by 2. So this equals negative 2,400 plus 12 times 400 is 4,800. So $2,400. And that's the consumer surplus. So all of these perceived savings, right? And again, it's an illusion, right? You think you're saving money because you're spending less than what the demand curve implies, right? I mean, remember, again, I don't know if I made this clear when we originally learned about price and demand, but I mean, if the price was, what did we say, $21, there's already 100 units that are demanded, right? So it's as if you can count on these 100 people, let's just call them people, right, buying your product, right? Or you can count on, 50 people buying 2 of them, whatever you want to say. All right. I like to think of each unit as a person. So, because assuming they're only going to buy 1. So 100 people are already going to buy the product at $21. So if you lower the price to $19, right, or $18 or whatever, you're going to get the same 100 people are going to buy it. And so you have all of these possibilities. You add up all of these possibilities, and this area here is the consumer surplus. And again, I hope I'm explaining that clearly. I'm a mathematician, not an economist, but I do have a pretty good idea of how the math works. So let's move on to the other way, which is the producer's surplus. So for the producer's surplus, you look at the supply curve. Which, what did we say that was? That was a 0.01x plus 8. So that crossed right here at 8. There's the y-intercept, which was 8. We still have the same equilibrium, which was 12. And then this is 400. So this is the point 400, comma 12. So similarly, consumers are trying to save money, right? That's how you make people buy stuff, is you make them think that they're saving money. So we call that perceived savings, right? Well, with the supplier or the producer, also called the supplier, or the dealer, they're the ones that's producing or supplying the product, has a perceived gain right by selling each item at a price below equilibrium. Right? So again, it's the same concept. If you sold 200 items, right, at a price below $12, so say you sold it for a price of, I don't know, $10 or something, right? And again, I'm just making that up. Right? I'll do the exact math in a minute. But the idea is that there's a perceived gain from the producer by selling the same number of items at a price that's below the equilibrium price, but is above the supply curve. Right? Because think about it, if X was 200, the supply curve says if 200 people are buying it, what should the price be? I do like to play around with the equations to kind of show you. The price should be $9, right? Or no, $10. Yeah, exactly. 0.01. I actually guessed that one correctly, believe it or not. I don't have to fudge the numbers. So this would be 2 plus 8, which would be 10, which is exactly what I just said. So if the price was $10, then the demand would be 200 people, again, or 200 units or 200 items are demanded at a price of $10. Yeah. And so the supplier is saying, well, the equilibrium point is 12, right? They were willing to pay 10. So I'm gaining. There's a perceived gain by selling the item at a price that's below the equilibrium. Right? In other words, I don't have to charge $12. I could charge $11. Right? I can charge anything between 10 and 12. Yeah. And that's for this number of units. As you get closer and closer and closer to the axis, there's all these different possibilities until you reach the equilibrium point. So you have all these possible gains or perceived gain from the producer. So we call this producer's surplus. PS, I guess. And that's going to be the integral from 0 to x0. Remember, x0 is the x coordinate of the equilibrium, and then p0 is the y coordinate or the p coordinate in the market. Okay. And then this time you reverse it because remember the rule for area between curves, you have to take the ceiling minus the floor. So the ceiling is P0 minus the floor, which is the Sx, and then do that integral with respect to x. Okay. All right, so I guess I'll just call this example 2. Find the producer surplus. So we got PS is the integral from 0 to 400 of 12 minus, now be careful with this one, I would add an extra set of parentheses here so that when you put in your supply function, you don't mess up the signs. So it's going to be the integral from 0 to 12 of 12, from 0 to 400 of 12 minus 0.01x minus 8 dx. The integral from 0 to 400 of negative 0.01x plus 4 dx. So the negative 8 and the positive 12 give us this 4 here. All right. So a lot of it is in the setup. Set it up correctly, and then solving it should be pretty easy. So that's going to be the antiderivative, negative 0.01 x squared over 2 plus 4x evaluated between 0 and 400. And you might as well just ignore the 0. And there you go. At this point, it's just a calculator problem. So we got 400 squared. I already knew what that was, 160,000 times 0.01. So negative 1,600 divided by 2. You might notice some neat patterns when you do this. And then that's going to be 1,600. Right, 4 times 400. Very similar pattern. We've seen this before. It's kind of how you know you've done it right. At least for the linear graphs, you have a very clean pattern because it's a line, right? Even though we call it a curve. And again, that's $800. So in this particular market, the producer's surplus is $800 and the consumer's surplus was what? $2,400. Consumer surplus. So there you go. That's your Economics 101 with calculus. If we had more time together, we might be able to dive deeper into the theory and see some more exotic examples of nonlinear curves in the future. But I think for today's lesson, we will end here with my final example. So given a demand function and a supply function, find the equilibrium point. And the consumer surplus and producer's surplus. So basically do everything. You don't really need to draw the graph. I mean, I considered having some graphing problems here. I actually like to think about the graph without actually drawing it. So you have your S is the increasing one, your D is the decreasing one. It just kind of gives you an idea of what you're trying to find. We'll call that E for equilibrium. Right. These types of supply functions, I think, to me, intuitively make more sense because they start at 0. So that's one of the reasons why I like to use these type. They intuitively make a lot of sense because if you have no demand, then why would you even supply it, right? So if you plug in 0 for X, your supply and your demand are 0, right? Nothing. Nobody wants it. So don't even bother supplying it, right? All right. So pretty easy to find the equilibrium point. To find the equilibrium point, set d of x equal to s of x. Just like that. Or you could do s of x equals, it doesn't matter. As long as they're equal to each other, it doesn't matter what side they're on. For this particular one, I actually wish I would have gone the other way. So I'm going to break with convention and I'm going to go from left over to the right side. So I'm going to get 400 equals 0.8x. I'm going to divide by 0.8. And that's going to be my x. So if you can do that in your head, that's great. $400 divided by 0.8, 500. So that's your x sub 0. When we're solving it, I usually just call it x, just because I don't like writing x sub 0. The subscript is annoying. But when you actually finish the problem, it should be your x sub 0. So that's 500 units or 500 items or whatever it is we're talking about. Okay. And then now to find P0, remember it's equilibrium. So if you plug 500 into either one of these, they both should give both equations should give the same price. And again, I underline the word should because I don't know if they do, you have to plug it in. So plug in 500. Right. Again, that's only true for the equilibrium because that's the price at which they're equal. Right? So let's see. Let's see if they do. Negative 0.4 times 500 plus 400. Negative 200 plus 400 is $200. Wow, that's an expensive item. Right. $200. Well, I don't know. Is $200 expensive? I don't. It depends. Compared to the last thing we were selling, which was a $12 item. $200 is the equilibrium. Let's check the supply curve just to make sure. It's check. I don't even have to do it. I already know it's going to be right. 0.4 times 500. Check. It's 200. Yeah. So the supply and the demand should equal each other at the equilibrium point. So this item's a $200 equilibrium price. So now we can find the consumer and producer surplus. So CS, the integral from 0 to 500 of d of x, negative 0.4 x plus 400 minus p0, 200. So now I take my antiderivative, negative 0.4 x squared over 2, and then 200x. Why don't I just plug in the 500 and be done with it? So 500 squared, 250,000 times 0.4 negative 100,000 divided by 2, negative 50,000, right? And then 200 times 500 is 100,000. You'll see a pattern here. It's a pattern we've seen before. So the consumer surplus is $50,000. All right, let's write that over here. CS is 50,000. That represents the area here. That's the consumer surplus. And finally, producer's surplus. Let's see if we can redo this. So we're going to do the 200 goes first. That's your P0. All right, that's your equilibrium price minus the SX. I don't really need the extra parentheses because the supply function is very simple with respect to X. So I've got, for this one, I'm not even going to simplify it. I'm just going to leave it the way it is. 200X minus 0.4 X squared over 2. I could simplify this because 0.4 is divisible by 2. I didn't do that last time, but if you're watching the video and you're wondering why didn't I simplify it, I just didn't. But I mean, I don't know what you're going to get. You might not get 0.4, right? You might get 0.5 or 0.3 or 0.7 or some other number that's not nicely divisible. But if you get something that you can simplify, it's not going to change the result. All right, and again, you're really just plugging in the upper limit of integration. So 200 times 500 is 100,000. And then 500 squared, 250,000 times 0.2. Oh, look, they match. That's a coincidence because the slopes, see how the slopes were opposite of each other? So you get the same for the PS, which would represent the area underneath the equilibrium. Well, if we had more time, we would get into some more examples, but I'm really starting to get out of my lane. You know, I'm getting more into the economics course. If you are a major that requires economics, you might see this again. I'm not sure, depending on what level of economics it is, whether or not you'll use calculus or not. These particular results can be obtained without calculus. But since this is a calculus course, I used it as an opportunity to demonstrate the definite integral. If these curves were more curvy, if they were more complicated, they weren't straight lines, then the calculus would be a necessary function, which is really what I demonstrated it for. Unfortunately, we are at the end of the semester, and so I'm not going to have time to post any additional, at least not for this particular semester. If you're watching this in the future, there might be a part 2 or 3 or something. I don't know, but until that time, I'm Dr. Jordan, and I'll just have to see you on the internet.